All right. So, like I was mentioning, a lot of you start joining WebAssign. That is great because we have our first quiz this week. So hopefully you guys will take it over there and have fun. I'll talk more about that in a few minutes. Now, I also want to mention, try not to post anything on chat when I'm lecturing and use your audio to communicate and share your answers. That way, I don't have to keep coming back to the chat, okay? Um, Another thing I want to mention is those of you who are coming in now, it's okay, it's 10:02, but try to be here before 10, at least like 9:59-ish, 9:58, so that way you're here on time and we can start exactly at 10, okay? So let me go ahead and share my screen with you guys. That way we can go over the syllabus if you're here for the first time quickly. So just like last time I showed to you guys, you can find our course syllabus from my page by going to this department website and then go to people, look for my name. Hopefully you know my name by now. So here's my name. I'm Jania Begum. That's me. This is my page. And once you're in this page, you can access the course syllabus by clicking here, Fall 2020 Math 190 students, click here. So you click here, you are able to see the course syllabus. And the way you make the purchase for WebAssign access code is by clicking this link. And once you're on this link, it takes you to this page and scroll all the way down to get this version of the textbook, which you can get it for $40. Now, if you are ECI student, there are a couple of you, you know what I'm talking about, send me an email saying that you're an ECI program, okay? So those of you who are in that program, after class today, send me an email saying that you are in the program. Does that make sense? Yep.
So Sophia, Ms. Bogue said to just do the trial, and once we finish with that, she'll give us the access code. So we're good for now for 2 weeks. Yeah.
Yep, absolutely. Thank you.
You're welcome.
I sent her an email yesterday, so she has all set up for you guys. So if you're an EC program, still send me an email. That way I know who you are, and then I can distinguish you from the regular students. Make sense?
Yes, sounds perfect. Thank you.
All right. So, okay, so that's covered. Uh, and then, so you guys don't have to worry about buying the textbook because Sophia will take care of that. So cool. But rest of you, this is how you will be getting your access code for WebAssign, and you'll be saving a lot because you'll charge you $40 instead of 100 something. I have no idea what their rate is. Okay, so that's our course syllabus. And then last time I also showed you how to access my website. So my website is this link right here, which is homepage. If you click on it, it takes you to my website that I have created for my teaching courses. And on teaching, you go to our course 190 and you're in section EC. So you'll be clicking on the red one and it takes you to a PDF file where I explicitly wrote out how to get access to WebAssign. So hopefully you guys did that, and a lot of you did it, so good job. There's a few of you, so make sure you get it probably end of today. That way you can do your homework P1 and P2, and then the quiz will take place on Thursday. And the next thing I want to mention is the YouTube videos for our lectures. So if you go to videos, here is the playlist for our section EC. You can click on that. It's a hyperlink, and it will take you directly to my YouTube channel. So that's what we talked about last time, and then we did a little bit of P1 section from the textbook. Any questions on that? All right. So Alexis?
Hi, good morning. Can you hear me?
Yeah, I hear you. Good morning.
Okay. I actually have a question about the homework assignments. So when I went on WebAssign and I looked at the dates provided for the assignments, there weren't only two homeworks due for Wednesday. There was actually three. So do we have to do all three of those?
Right. So there's 3 homework due on September 6th, But the
Okay.
quiz will only have P1 and P2.
Okay, thank you so much.
No problem. All right, so I will write all of that down here in my own note so that way you have it all written up. Okay, so again, if you have a question, please use your audio. Try not to post anything on chat. That way you don't distract the class, you don't distract me by keep going back and forward. All right, so let me just write all of this down. That way we have it all in one page, and hopefully we don't forget. So I already spoke to those of you who are in EC program, so update. So one, if you are in ECI program, send me an email. Okay. All right. Okay, good. So those of you who are in ECI program, send me an email just saying you're in the program. That's it. You don't have to write anything else unless you want to. And then second update I have is get started with WebAssign. So for this coming week, you have 3 assignments due. So P1, P2, prerequisite, right? That's what P stands for. P3, these are due on September 6th. I believe that's this weekend. So just make sure you finish those up. This date is fixed. I won't change it. So make sure you get it done before September 6th. Of course, your internet is not going to work midnight of September 6th. So don't make that as an excuse. I'm not going to push the due date. So make sure you finish up by the 5th. That way, when the 6th comes, you don't rush to finish those questions. And if you look at those questions, they're not really long. They're just 10 questions per assignment or maybe 12. So I'm sure you can do them in a day or two if you just split them up. If you have your audio
you can
on,
access
please.
I'm sorry.
Okay, go ahead. Do you have a question?
I have a question. You can access the WebAssign through the CUNY First website.
No, WebAssign is not CUNY First. I just showed it to you guys how to access that. WebAssign is you have to go to my website, and then here's the description. Click here if you're in section EC. If you click on that, you'll see how to get started with WebAssign.
Okay.
Yeah. All right. Okay, cool. So can you mute your audio? That way it doesn't distract on the background. All right. So question?
Hello, can you hear me?
Yeah. Uh-huh.
Hi. So when you were speaking earlier, my website said I wasn't connected, and it said it was reconnecting. I don't know if you went over this already, but when we take the test, is the test on WebAssign or is the test on Blackboard?
I'm gonna mention it. I haven't mentioned it. Okay. All right. So homework is right here. Now the next thing I want to mention is your exams and quizzes. So exams and quizzes. I mentioned last time that they're going to take place on WebAssign. There is a slight change to that. I spoke to the course supervisor, and he agreed to give exams on Blackboard as well. So we'll have our exams on Blackboard or on WebAssign. So there's going to be 2 places where you'll have your assessment. I'll let you know ahead of time which place the recording question will be on. Okay, so if the quiz is on Blackboard, I will tell you it's going to be on Blackboard. If it's on WebAssign, I'll tell you ahead of time. So you'll be assessed in both platform, not just WebAssign. Okay. And also, I mentioned last time that it's the beginning of the class. I'm changing that to end of the class. So that way you all have enough time to finish the exam or quiz. So to modify that, it will be at the end of the class. Okay, so if you look back at my first lecture, it's going to say beginning, but now this is the confirmed word that it's going to be at the end of the class. So if you have to take extra time, you can go over 11:40. That way you wouldn't be distracting the entire class, because some of you are in that special program where you need more time, and I have to accommodate that as well. So that's why I'm putting it at the end of the class. Any questions on that? Okay, make sense, guys?
Yeah, you
Yes.
have no idea how relieved that just made me. Thank you so much.
Okay. All right, no problem. All right, so that's been modified. Hopefully you guys keep this in mind. Now talking about our first quiz, that's the next update. Our quiz 1, that's going to be on WebAssign. Okay, so this will take place on WebAssign. And this is going to be for 20 minutes, like I said last time. And it will have about 3 to 4 questions. Okay, so not too long. You can finish within 10 minutes, but take your time. Don't just submit an answer, because once it is submitted, you can fix it to go back. So just be careful how you answer these questions. And this quiz will have section P1 and P2. Okay. So that's all you have to know what's coming up for Thursday. Now, because it's at the end of the class, so we'll finish class around, let's say, 11:20-ish. So that way you have 20 minutes to finish the quiz. So this will start at 11:20. Any questions?
That's
Yes, that's this Thursday. So I didn't put the date. What's the date for this Thursday?
Shouldn't it
Second?
be on Wednesday because we have classes on Monday and Wednesday?
Yeah, right. Sorry, not
Okay,
Thursday.
yeah.
Second, right? Yeah, Wednesday. This is Wednesday. Absolutely. Thank you.
You're welcome.
All right. So any other questions, concern?
Yes. You said that
Uh-huh.
if we need more time after 11:40, we can. Is that only for the guys in the special program or also for regular students?
It's only for those who are in the accommodation program. If you have the form approved by accessibility, you give it to me and then you get the extended time.
Okay, perfect. Thank you.
Yep. And everyone will have 20 minutes. Just for those who gave me the form will have extra minute depending on what your accommodation is. Okay. All right. Any other questions? Yep. Go ahead.
Okay, so for the quiz, when class ends at 11:20, do we leave the session and then log into WebAssign and take the quiz, or like how's the process gonna work?
Well, you could leave this on and then just open a browser for WebAssign and then keep working on it.
Oh, okay.
I'll be here in Blackboard until 11:40.
Okay, thank you.
Yep, no problem. And another thing to keep in mind, there's no calculator for any quiz or exams. So just keep that in mind. Don't use any resource. Don't use any calculator. Be honest with yourself. This is your learning experience, so make sure you get the best out of it. Okay. Okay. Any other questions before we start? All right. So we're gonna go ahead and start. So last time we were talking about prerequisite sections and we finished P1. So P1, we did modeling, Now, I would like to just continue that and just give you guys a few more questions to work on. So let's continue that. Just a couple more minutes. Now, we talked about how you can have a real world scenario, and from there you can create an algebraic formula that will relate the scenario you're given. So the way we do is we introduce variables to stand for a specific quantity and somehow relate and create an algebraic formula. So that's what we're gonna do, and just create few more formulas and see how useful this is. So let's look at this one. So here's an example I want to work on. So say the distance d driven by a car traveling at a speed of v miles per hour for t hours. And it's given by the following formula. So if you remember, we measured distance is equal to the speed times time. You might have seen this earlier in your studies, or you might have seen your speed is equal to distance over time, right? It's just manipulating one formula to get the other. So using this formula, if a car is driven 70 miles per hour for 3.5 hour, how far has it traveled? Right? So I'll give you a few seconds to just write down your answer and I'll work it out. So we're going to be using this formula, or if you like to, I like to remember using the second one. Speed is equal to distance over time. But if you like distance is speed times time, that's also fine. Any of these formulas are fine because they're the same. So if a car is driven 70 miles per hour, which component is 70 miles per hour? Someone tell me.
That would be the distance.
I
That would
wouldn't
be
say
velocity.
that would be velocity, right? Because velocity is, if you look at the unit, it's mile per hour, right? Distance will be the units of miles. So this would be velocity. For 3.5 hours, which component is this one?
Time.
Time.
Right. Alexis, do you have a question?
No.
Okay. Tamanna, you have a question? Okay,
No.
I'm not sure who had a question, but yeah, just be friendly with your classmates. Just go one at a time. That way, no one gets cut off. So also try not to post anything on the chat. Like I said earlier, you don't need to put anything on the chat. That way, I don't need to keep coming back and forth, and it's kind of distraction as well. So try not to do that. Speak through your audio and be friendly with your classmate when the other person is talking. You might want to just, be friendly with them so we all can hear. So 3.5, a lot of you said that's T, good. And how far has it traveled? Well, that means we're looking for D, the distance, right? So we know the formula, distance is equal to the speed times T, and you're given the speed, which is 70 miles per hour. And we have time, which is 3.5 hour. And you see the hours will cancel out, so your units will be in miles. Okay, questions? Okay, please mute your audio, that way it doesn't distract anyone. Okay, so when you do 70 times 3.5, what do you guys get?
245.
245.
245 miles.
Absolutely. There you go. So that's how far we traveled. All right. So once you finish answering the question, please mute your audio so that way we don't have a lot of background noises. Okay. Here's another question that I would like you guys to work on. So actually, I have it cropped right here. So I'll give you guys about like 30 seconds. It shouldn't take you more than that. Try to see if you can answer this problem. And I'll go over it in a few seconds. Question? Did someone had a question? Okay, I missed that hand, but you can speak if you have a question. Okay, I assume not. All right, so let's go ahead and answer this question. So we're given a formula, okay, so we don't have to come up with it. Nice. Volume is equal to pi times r squared times h, where r is the radius and h is the height of the can. So if you want, you can draw the cylinder and kind of picture what's going on. So here is a cylinder. So I don't really draw great because I'm not an artist. But let's just say that's the cylinder we're looking at. Okay. 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 And r is this distance right here. So that's r. And height is this distance right here. So we want to find the volume of a can with radius 3. So r is 3 and height is 5. Okay. All right. So all you have to do is plug them in, right? So plug them into the formula and you should have the value you're looking for. So the volume is going to be pi times r squared, so that's 3 squared, times the height at 5. So this would give us pi times 9 times 5, and that would be 45 pi. Did you guys get this?
Yes.
Yes, got it.
Great.
I have a question,
Wonderful.
Professor. You could break
Go
down
ahead.
pi or no?
So I wouldn't break down pi because on WebAssign or in Blackboard, it will be acceptable this way.
Okay, because as long as I know, pi is 3.15, right?
Right. 14.
3.15.
So I wouldn't break down pi because we wouldn't have a calculator, so you wouldn't want to multiply 3.14 and that huge expansion to 45. That's a mess. So leaving it this way is acceptable.
Okay, thank you.
No problem. All right. Here's another example. So let me put that down here for you. So for the remaining ones, you want to kind of model and come up with an algebraic formula. So let me give you a couple seconds to do that. So okay, so come up with an algebraic model. And here's the next one. So I'm just going to put them in one page. That way we have it all together. Okay, so for number 3, let's have Edwin tell us what's the formula for this. Edwin, if you're here, you can use your audio to respond.
For example 3, right?
Yep.
So the model I used for example 3 was C equals 3.50x.
Perfect. Any questions on this? All right. Go ahead.
No, that's pretty.
Okay. All right. Great. Moving on to the next one. Let's have Raghav tell us the formula for number 4.
So I did to A plus B divided by 2.
So that's the formula for average of 2 numbers. Any questions on 3 and 4? All right. I have one more example for you before we finish this section. So here's the next one. Again, come up with the model. So I'll give you a couple of seconds. All right, let's hear Aza. What do you have for number 5? Okay, Aza, are you there?
Oh, sorry. Haha. All right.
It's okay.
So, and then I just kept talking. All right. Hello. Okay. The distance. So, in this case, your formula is going to be D equals the 60 miles an hour times time.
Absolutely. All right, so there you go. So you should be able to use the formula to get to some quantity you're looking for, or if you have a scenario, you should be able to create a formula based on the knowledge you have. Any questions on P1? So that's the end of P1. Now we're going to move on to P2, and we'll work with real numbers. Okay. So P2 is called real numbers. So we want to talk about the construction of the real line before we start doing any other application. It is important to understand how the real numbers are structured, how it is created, so that we're familiar with the number system. So real numbers, we're going to use the symbol. So we'll denote them using the symbol, this fancy looking R. R means real numbers. Okay, now how is it constructed? Well, before we start talking about real numbers, we need to start from the scratch. We need to start from natural numbers. So we start with natural numbers. And natural numbers are denoted by this symbol N for natural, right? So what are natural numbers? Well, natural numbers are counting numbers, right? When a child starts to count, they will count 1, 2, 3, 4 based on maybe how many fingers they see, right? Probably, I'm not sure how they start counting. But you'll start counting 1, 2, 3, 4, and so on, right? Just the list keep going forever. And we have a symbol to represent forever. Hopefully you guys know that. Do you guys know what I'm referring to?
The infinity?
Infinity.
Infinity?
Yeah. Right. So we use infinity to kind of, oh, okay. I don't really write infinity good, but this means infinity. Okay, so if you're not familiar with it, infinity is just a symbol to represent the 3 dots are just going to keep going forever. So you can go all the way down to 10,000, 100,000, million, so on. Now, once we have the natural numbers, then we can build up to another number system. We can say, oh, we can talk about integers. So then we have created integers. Integers, we use the symbol Z. This fancy looking Z is denoted for integers. Now, integers are natural numbers with their negatives and including 0. We have more negative numbers than say -3, -2, -1, 0 in the middle. Then you have 1, 2, 3, and so on. And then because in both direction I put dot, 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 I'm indicating I'm extending it to the left side and I'm extending it to the right side. Positive integers and negative integers. So on the left side, we're using negative infinity to indicate negative integers. And on the right side, we have positive infinity. So indicating positive big numbers such as, 10,000 and so on. And then from integers, we can take it further. We start talking about rational numbers. So we have rational numbers. Now, rational numbers is denoted by this symbol Q. And rational numbers are numbers in the form, so I wouldn't be listing them, but they're just the numbers in the form of A over B, where B is not 0. Okay? And A, B are integers. So they're integers, but making sure B is not 0, because if B is 0, then we're in trouble, right? So we want to make sure B is not 0. So few examples of rational numbers could be 2/3, -5/2, you name it. List them out. Just make sure you don't put 0 on the denominator. A nice one, 1/2, right? 1/2 is nice. After we have created rational numbers, we can now start talking about irrational numbers. So irrational numbers are funny. Now, what are irrational numbers? Do you guys know? Anyone? Go ahead.
Numbers that you can't represent accurately with a ratio.
Right. So give me an example of irrational number.
So like the square root of 2, for instance.
Perfect. Right? Very common irrational number, square root of 2. Now, if you put this in your calculator, you'll see it gives you a huge expansion, 1 point whatever. I don't remember. It's a huge expansion. It repeats without a pattern, so you can't really represent using a ratio of 2 numbers. So that's an irrational number. And irrational numbers are denoted by this symbol I, and that's one example. One of my favorite is pi. And I happen to remember a couple of digits of pi. Pi is 3.141592653589799. 323. I don't remember what's the next digit, but I think it's 323 question mark. You can double check that. But up to 79 is okay. Yeah, I'm kind of forgetting what the next digit is. Yeah, oh, yeah, let's come back to that later. But I did do this for a fun exercise to memorize as many digits of pi as possible. And I was able to get up to 323. I think that's the next digit. I'm not sure. I'm forgetting it right now because I haven't been practicing, writing down pi. But those are the digits. Now, if you try to look for any pattern between these numbers, 14, 15, 9, 2, 6, 5, 3, 5, there's no pattern. They're just coming out from the blue and you just can't see any pattern. So that's why we say pi is an also irrational number. And same thing for square root of 2. That's about 1.2, blah, blah, blah. Right? Who cares what is? It's irrational. And another one, very well known, is the number e. And for e, do you guys know the expansion for e?
As well.
It's about 2.718. Yeah, that's all I know. So not a big fan of e, but that's also an irrational number. Okay. Now, after we have constructed the irrational numbers, now putting all of these together, we are able to create the real number. So then we have real numbers. And real numbers are denoted by big R. And real number is natural numbers, rational, integers, rationals, and irrationals. Okay. So the real number system is composed of natural, integers, rationals, and irrationals. Altogether, we call them real numbers. Now, if you look at real numbers, they're really well structured and they're in order. So if you draw the number line, the horizontal line, we call this the number line. This is the number line. And here we, at the center, we put 0. And to the left of 0, we have all the negative reals. And to the right of 0, we have all the positive reals. So I can order them as 1, 2, 3, 4, and so on. And on the left side, we can also order them using negative reals. -1, -2, -3, -4, and so on. So here's the extension, negative infinity and positive infinity. So that's the real line. It's well ordered and well structured. Okay, it's well ordered because obviously 2 is right after 1, not it's 1, 3, 5, 7, whatever. It's well ordered. And also, if you want to locate pi on the real line, pi is somewhere here, right? And if you want to locate square root of 2, that's right here. And if you want to locate e, let's say that's right here. So I'm just locating them so they're in structure. And also, if you want to locate the fractions, we have a half right here, -half here, and so on. So hopefully you get the idea. The real number is in order. Okay, they're not all over the place. Now that we discover what real numbers are, now we can start talking about their properties. There are 3 main properties of real numbers. So, properties of real numbers. So there are 3 major properties of real numbers. Make sure you know them by name and know how to use them as well. So one of them is called the commutative property. So before I do that, let A, B, C be real numbers. Okay, so I have a symbol here that I need to introduce you to. This symbol, it's called epsilon. It's a Greek symbol. This means belong to. Okay, so when you study pure mathematics in a higher level, we often use more symbols than words. So you will see ABC and that epsilon symbol and R, that means ABC belong to the real numbers. Okay, so just making you familiar with this symbol, that way you know how to use them in the future as well. So commutative property says, so if I have, say, two real numbers, A plus B, it's same as doing B plus A. So that's a commutative under addition, okay? Now, you can also do under multiplication. AB is same as BA. You guys agree?
Yes.
Right? So you probably
Yes.
have
Yep.
seen this before. Cool. All right, so great. Commutative. I don't think I need to give you an example. Hopefully it makes sense. But if you do want to see an example with real numbers, like actual numbers instead of A, B, C, you can think of, say, 7 plus 1 is same as 1 plus 7, right? That's true. Or if you want to test it out with multiplication, think of 6 times 2 is same as 2 times 6. It's true, right? Both sides of the equality. All right, so next major property we want to write down is called the associative property. So take three real numbers. So again, under addition, you have A plus B plus C is equal to A plus B plus C. So this is under addition. If I parenthesize AB and then add the result C, it's same as doing BC and then add the result to A. Okay, so you can put parentheses in any order. That's what the associative property tells us. And under multiplication, you can also do the same thing. If you do A times B times C, do the parentheses first and then multiply by A. It's the same as doing AB first and then timesing it with. Okay, so you can put parentheses in order and it's still whole. Again, if you want an example, think of an example for, think of a real number for ABC and plug them in and you'll see that it's a whole. This property we have for a real number is the distributive property. Now, there's two types of distribution, left distribution and right distribution. So we'll break this down into two cases. So if you have A times, and here distribution just means multiplication, right? So if I distribute A to B and A to C, I have A times B plus A times C. So the value I distributed is on the left side. So we call this the left distribution. Okay. And then I can put the A on the right side of the parentheses and you know you're going to call it the right distribution. So we can do A, sorry, not A. Let's keep it consistent, right? B plus C times A. Again, I'm going to distribute A to B and C, so that would give me A times B plus A times C. And because A is on the right side, we call this the right distribution. Okay. Again, you can put in real numbers into A, B, and C and come up with an example for all of these properties. So these are the three major properties that we can apply to any real numbers and it will still hold. Okay. Now, I I want to do a few examples, but before that, I want to go over a few more properties, and then we'll just do a bunch of examples at the end. So the next property that I want to bring it to your attention is the property of negative numbers. So negative reals, we also want to give them special attention because you know what happens when you multiply two negatives, right? So we want to keep that in mind before we apply applications to them. So now I want to talk about properties, because there's couples of negative real. Okay, so we want to give our attention to negative reals too, because we can just multiply them how we want. They behave a certain way. So the first property that I'm going to state it for you is if you have a negative 1 times a number a. So again, consider, let's use just a and b. Consider a, b are any real number, okay? So if I have negative 1 times a, well, that just means this is negative a, right? Negative 1, you can kind of ignore the 1. 1 is always invisible, so we just write negative a. The second property of negative we have is if you have negative times negative a. Do you guys know what this is?
Positive a.
Positive A.
Right, absolutely. So again, you can think there's a invisible 1 with that negative. So you have negative times negative. So double negative is a positive. So we have positive a. And then the third property that I want to write down is if I have negative a times negative b. What's the result for this?
AB.
It's positive AB.
Positive AB.
A times
Positive
B.
AB.
Absolutely. You guys got it. All right, moving on to the next one. So you can kind of see, if you know the first and second, you can modify this and then use the first 3 laws we have, or the properties I called them earlier, and modify them, right? So for example, if I have negative a plus b, here I have a negative 1 you can think of is on the left side of the parentheses ab, so I will be using the left distribution property from previous section and then apply it to this. So we're going to distribute a negative 1 to a and b. That would give us negative a minus b, or plus negative b, which will just be negative b. And then again, using the same rule, I can also do negative a minus b, right? Again, left distribution of negative 1. So that would be negative a minus negative b. Well, what's negative negative b?
Positive.
Right. So that would be negative a plus b. And we usually like to write positive number first. So you can also rewrite this as b minus a if you want to switch the order, but negative a plus b is also acceptable. So, and then you can play around with this, right? But the main idea of this property is 1 and 2. And then from there, we start using the associative and commutative and distribution from previous one. Okay, having said that, now we want to talk about rational numbers, because rational numbers, they also behave weird when you start applying operations to them, okay? So let's talk about the properties of fractions. Okay, so, well, let's see, right? So let A, B, C, D be real numbers, okay? And here's some properties we want to apply. If I have A over B times C over D, so I have 2 fractions, and I'm making sure B and D are not 0. How do I multiply 2 fractions? Well, first you try to reduce them, but here it doesn't look like we have any common factor. So we're just going to go ahead and multiply them horizontally. So we have A times C over B times D. That's how we multiply fractions. Now, next thing is, how do you divide fractions, right? If you have a over b divided by c over d, so division, we can't really divide them, so what we do, we change it to multiplication and we reciprocate the second fraction. That way we can use property number 1. So we keep the first fraction a over b, change the division to multiplication, and then reciprocate the next fraction. That would be d over c. And now from here we can use property number 1. That would give us a times d over b times c. So that's how we divide two fractions. Now, division can also be written in another way. So division can also be written this way: a over b over c over d. Right? So that's another way to write division. Again, you'll do the same thing. You'll keep the top fraction, ab, change the division to multiplication, and reciprocate the bottom fraction. So that would be d over c. And then again, you get the same result, a times d over b times c. Okay? So very important, the first rule and the second rule. You will often see them with real numbers, so be familiar with them. Now, next rule I'm going to write down is addition. If I have a over c plus b over c, when I'm adding two fractions, well, I just add them up, right? I have to make sure they have the common denominator. What do you guys think?
Yeah. AB over C.
Right. So because this one.
A plus B over C.
Right. So because they have same denominator, which is C in this case, I am freely adding up the top, or I can also subtract. So addition and subtraction works the same for two fractions. As long as they have same denominator, you can add or subtract the top. So we add or subtract the top, but keep the denominator same. Now, what if, right? What if you have AB plus CD? Now, I want to add these fractions, but I don't have same denominator. So let's hear from, let's see, Alejandro. Tell us, how would you add these two fractions?
So I would multiply AB by D. So I'd multiply the numerator and the denominator by D. And then I would multiply the numerator and denominator for CD by B.
Absolutely. So Alejandro looked for the LCD, which happens to be B times D. And then you give each fraction what they're missing. The first one is missing D from the denominator, so you multiply top and bottom by D. And the second fraction was missing B from the denominator, so you multiply top and bottom by D. Sorry, B. So thank you, Alejandro. So this would give us AD plus CB all over BD. Okay, so you have to do extra work, a little extra, when the denominators are not the same. And the same will go for subtraction. So if I put a subtraction there, you still have to get common denominators, and then you can proceed to subtraction. Very useful properties when it comes to fractions. All right, so pretty much we covered, so we covered negatives, we covered fractions, and then we talked about the properties. All right, sounds good. Okay, now let me give you guys some examples to work on. That way we're not just keep talking, right? So here are some examples for you to work on, and then I will just call on you guys to share your answers with me. So so for first few, I want you to state the property of real numbers. Okay, so here you go. Question? Does someone have a question? Okay, so let's do the first four, and for maybe next 2 minutes, and then I'll go over it and I'll just call on someone to help me with the answers. So be prepared to share your answers. And I heard someone raise their hand, but I missed you. But if you're still here, you can ask your question. So don't forget, guys, I'll be taking your attendance, so try not to leave the session.
Professor, can you go back to the questions?
Yeah, I will. Let me just go through the attendance for next couple of seconds. Sorry.
Thank you. It's okay.
All right. There we go. Question?
After we finish answering the questions, can you like please go down the scroll back up to the list of properties again, please?
Sure.
Okay.
All right. So hopefully you guys had enough time. So let me go back to the properties so that way we can answer these questions. So here are the 3 properties of real numbers that I wrote down earlier. We have commutative, we have associative, and distributive. Non-distribution, we have 2 types, left distribution and right distribution. So knowing these properties, hopefully you know them by your heart or brain, whichever organ works the best for you. So, and now go back to the problem we had. For the first one, so let's hear from Jordan. Tell us what's the property being used for number 1.
Distributive.
Which distributive?
Left.
Left, right. So we're reading 4, which is located on the left side of the parentheses. So this is a left distribution. Okay, thank you, Jordan. Let's ask Daniel for the next one.
Sorry.
It's okay.
It's commutative, right?
Yep. Right, you can switch the order and the result's still the same. So 5 plus x is same as x plus 5. Good. All right, moving on to the next 2 problems. Let's have Kyra tell us the answer for number 3.
Hi. For number 3, I got 11 over 30.
Okay. So Kyra, tell us, how did you get to this answer?
So I multiplied 3 over 10 by 2. I multiplied 2 over 2. My bad, I'm sorry. I meant 3. I multiplied it by 3, both of them.
3 over 3?
Yeah, 3 over 3.
Okay.
And then I multiplied 1 over 15 by 2 over 2.
And then what did you get?
I got 9 over 30 plus 2 over 30. And then I added them.
Right. So there you go, 11 over 30. Thank you. All right, great. So hopefully you guys were able to hear our explanation clear, and that's the final answer, and I agree with that. All right, moving on to number 4. Let's have someone else help us out for number 4. Let's go to Paula. Paula, tell us, how would you approach number 4?
So sorry, I'm doing it right now. So we have to find the common denominator of 8 and 6, and I'm guessing that would be 24. So you would multiply 5 over 8 by 4 over 4, and then you will multiply 1 over 6 by... Oh wait, my bad. You will multiply 5 over 8 by 3, and you will multiply 1 over 6 by 4. Then you would do the math, add the fractions, and then I'm not sure what to do with the whole number. I'm thinking you would do 1 over 1 and get that to be the same denominator, then subtract it. I think. I'm not sure.
You sound right. So Paula is absolutely right. So the LCD is 24, right? 8 and 6, their least common denominator would be 24. If you use any other number, it wouldn't be the least common, so make sure you use 24. And then Paula told us, okay, multiply the second fraction by 3 over 3 and the last one by 4 over 4. So we have 1. Let's keep 1 waiting. We'll get to it. So we have minus 5 times 3, that's 15 over 24, plus, and then 1 times 4, that's 4 over 24. Now here you have options. You can go ahead and put the 1 as 1 over 1 and give its LCD, which is 24, or you can just go ahead and combine that and then add it to 1, right? Or subtract it to 1. But what I'm going to do, I'm going to take what Paula said, write as 1 over 1, so that you have all of them at the same denominator, and then multiply that with 24 over 24. Okay, so what we have all together is 24 minus 15 plus 4, everything over 24. So now every single term has the common denominator of 24. Okay, now once you do the calculation, now you can do 24 minus 15 first, and that would give us 9, right? And then you add 4 to that, that would give us 13. So all of this will come out to be 13 on top over 24. Any questions on this?
No.
All right, perfect. Now I'll give you another minute to work on number 5, and then again I'll randomly select a volunteer to help us out. Okay, so take a minute to work on number 5, and then we'll go over it together. All right, so hopefully you guys had enough time. So I'm gonna call on Jason to start us off with this problem. Okay, Jason, are you there? All right, no problem, Jason. So while Jason is doing that, we'll just take another minute to finish the problem.
Professor, can you go back to the problem?
Yeah.
Can you hear me?
Yep, I hear you. Hi, Jason.
Hello. All right, so I guess we should start with the top and find the least common denominator, which would be 30. I'm sorry, not 30. 10. And so it would be 4 over 10 plus 5 over 10, which is 9 over 10. And you find the LCD.
Okay. So we have. Go ahead.
Oh, and then you find the LCD for the bottom, which would be 30. So 3 over 30 plus 6 over 30 equals 9 over 30.
Oh, 9 over 30. Okay, so we have the fractions combined. Almost. We're almost there. How do we simplify division? Okay, go ahead.
I'm not sure.
Okay, no problem. Thank you, Jason.
Can I help?
Yep, of course.
All right, so what you can do is multiply the top fraction by 3 over 3.
Okay, so multiply top one 3
By
over
3 over
3.
3, that would be 27 over 9. Wait, that would be 27 over 10, the top fraction.
Mm. Well, why are you multiplying
I
the
mean,
top with
27
3 over 3?
to so we can finish the whole fraction. Like, I don't know how to explain it,
So,
but
so I
like,
wouldn't do that.
Wait,
Okay,
could
let's.
I help?
Help.
Go ahead.
Oh wait, now you go. Never mind.
Oh, okay. You basically multiply the reciprocal of the bottom denominator by the top by the numerator.
Right. So here we're gonna do the reciprocal of the bottom. So that'll be 30 over 9. Okay. Now, which rule are we using here? We're using this one, number 2, right? So you have division can be written this way, or division can be written this way. And the second version is the one we have. So if you have a fraction over fraction, you just want to keep the top, change the division to multiplication, and then reciprocate the bottom fraction. You don't want to multiply a fraction by any number because then you're kind of making the numbers bigger, which is no purpose of simplifying. So we wouldn't do that. We will keep the top, change the division to multiplication, and reciprocate. Any questions on that? So hopefully that makes sense. And now, how do we simplify this? We're almost there. Does someone help us out?
You will multiply horizontally and then divide that to get the whole number.
Okay. Or we can do something else. We can do better.
Oh, this is my.
We can simplify it.
All right. Asa?
I was gonna say this is my favorite thing about multiplying fractions is that you can reduce.
Exactly. So let's reduce it for us.
So the 9 numerator in the first fraction goes into the 9. You take they cancel out, so you have 1, and it goes into that once. And then you can do 10 goes into 10 one time, goes into 30 3 times. So now you're not stuck multiplying gigantor numbers.
Exactly. So if you're able to reduce and see such thing where top and bottom have a common ratio or common real number, let's say, cancel them out. Okay, so that way it's much simpler and you wouldn't end up with big numbers. So all of this will just reduce to a 3 over 1 or just simply 3. Cool. So we kind of used a lot of properties for this one question. We first used the LCD to combine the top fractions into a single fraction. We got 9 over 10. And then we combined the bottom fractions into a single fraction, which gave us 9 over 30. And then we did keep, change, flip. And that way we have our result 9 over 10 times 30 over 9. And then we reduce the fractions to get to the final answer, which is simply 3. So a lot of things involved. Just make sure you use all of them very carefully. And don't violate any because then you will end up on the wrong track. Okay, I have one more question for you and then we'll talk about intervals. So here's number 6. So for number 6, let's do 3 plus 1/4 times 1 minus 4/5. So I'll give you a minute to work on this and then I'll just call on a volunteer to help us out. Okay, so take a minute for this. All right, so hopefully you guys are ready by now. So let's have let's have Emily tell us how to start this problem. Emily, are you there? So looks like Emily is not here. All right, Emily is absent today. All right, Amjad, if you're here, tell us how to do this problem.
I would first multiply 3 times 1 and then 3 times negative 4.5.
Okay, so that's one way to do it. You can do distribution. So 3 times 1, and then 3 times 4 over 5th. So that would be one way to do it. Can someone tell us another way to do this problem? I think there's a shortcut to this.
Can I try it?
Yeah, go ahead.
What you could do is you could just simply calculate the sum of each individual parenthesis first. So you could do 3 plus 1 over 4. That will be 13 over 4. And then do the same thing with the other parenthesis, which will be 1 over 5. And then then what we're going to do is like multiply both the fractions to end up with 13 over 20.
Can you reduce this?
I don't think so.
No, right? Right. So if you couldn't reduce it here when you have 13 over 4 and 1 over 5, the result wouldn't reduce either. So, but still you want to double check. All right, so that's another way. This would be the quicker way to do this problem. Question?
Can you explain again on how she got 13 over 4?
So 13 over 4. So we combine these two into a fraction. So you write 3 over 1 and then look for LCD, which would be 4. So you get 3 times 4, that's 12, plus 1, that's 13 over 4. And then you do the same thing for 1 and 4/5. You give them LCD. So write 1 over 1, and the LCD will be 5. So that's 5 over 5. So then we have 5 minus 4, that's 1/4. And then once you're in this step, you can drop the parentheses because it's multiplication, right? And you see there's nothing that would reduce. 13 and 5 wouldn't reduce. 4 and 1, nothing in common. So we just go ahead and multiply them. So 13 times 1 is 13, and 4 times 5 is 20. And then again, if you want to check if there is a factor in common, there isn't, because 13, there is no other factors. It's just 13 and 1. 20 is 4 and 5. So that would be the final simplified answer. Okay, and if you approach the same way that Amzad told us, you can distribute 3 to 1 and negative 4/5, and then you would be distributing 1/4 to 1 and negative 4/5. So we'll end up with a lot of fractions. You can do it. It's manageable, but it's just going to take you an extra minute or two, whereas you have other simplified ways to attack these problems. So see which way works for you, see which property you like the most or which one is applicable, and then use it. All right, so any questions on these? All right, so if there are no questions, I'm moving on to the next part of still P2. So we want to talk about set and interval notations. Okay, so we want to talk about inequalities. We want to talk about notations such as using parentheses and brackets and so on. So set and intervals. So we want to be able to express a set using interval notation or inequality notation. But before we do that, we want to identify what is a set, right? So a set is a collection of objects, okay, or numbers in our case most of the time, or things, right? So a collection of objects. So if I say let A be a set, be the set containing only 1, 2, 3. Okay, that's a set. And let B be another set. Let B be the set 2, 4, 5. Okay, so here I have introduced two sets and they have elements. Elements are the, what are elements? They're kind of like the objects that are in the set. Okay, so 1, 2, 3 are the elements of A. 2, 4, 5 are the elements of B. Does someone have a question? Okay, oh, yeah, set and intervals. Did I? Yeah, sorry, I cut off my V. All right, so now you want to introduce few symbols to create new sets, okay? So we're going to introduce symbols such as this one, U. Do you guys know what this symbol means?
No. No.
That's a union.
Union, right? So U is for union. Well, what is union?
All the elements in one.
So it's the collection of everything, right? So whatever contained in one set, you also want to include in the other set. So it's collection of every element. So if I want to do A union B, right? I want to find what is this set is. Well, what am I looking for really? I want everything that is contained in A and that is contained in B. Collection of every elements that are in A and B. So this new set is going to be 1, 2, 3, because that's in A. And then whatever B, well, B has 2. Well, if the element repeat, you don't have to rewrite it, okay? Once is enough. So you would say just 4 and 5. So this new set will be the A union B. That's how we read it. And then we have another set notation such as this one. Now, Asa, do you know which one this is?
That is intersect.
Yep, this is intersection. So this is intersection. And intersection, the word itself explains what it means, right? Where the two sets or three sets have intersection in, or what they have in common. So only common element. Okay, or more than one. So if I want to do A intersect B, so can someone tell us what will this set contain?
2.
2.
There you go, right? Only what they have in common. Now, what if they have nothing in common? How would you indicate that?
It's gonna be null, I think.
Yep, the null set,
Yeah,
right?
no.
So we use that null set, or you can put the braces with nothing inside, meaning they have nothing in common. So this means the null set. Or you can say nothing in common. Or you can say empty set. Right? So there are multiple ways to express null set. So these are a few symbols that you should be familiar with and you should know how to use them. Know how to use union, know how to use intersection, and the empty set as well. Okay. Now that we know how to do this, we want to kind of talk about interval notation and inequality notation. So I use both at the same time, interval and inequality. Okay, So I'm like eating my words. Inequality notation. So these are very useful when you're expressing a solution, which we'll do in the later sections. But for now, we just want to know how to draw them and how to express them. So, any questions? All right, so let's look at an open interval, okay? So open interval. So I'm going to give you a drawing. Suppose here is A and here is B on the real line, and open circle, everything that's inside A and B. So that's a set, okay? The set is only from A to B. So when you're reading a graph on the real line, you're reading it from left to right, from lowest to highest. So in interval notation, so this is an open interval because the endpoints are open, right? So we have an interval notation. You have parentheses, A comma B. That's what it means to be an open interval. Now, what about closed interval? Do you guys know how to indicate that?
The
You just
brackets
fill
instead of the
in the
You two
parentheses?
closed circles.
Right, so in drawing, you'll have two closed circles. So let's say A and B again. Close them up, meaning you shade them. And you just shade in your set. I'm shading only in between them. And in interval notation, you have brackets A comma B. Brackets indicate closed sets and parentheses indicate open sets. Now we're going to translate this into inequalities because they're exactly the same, just different notation. In inequality notation, we want to use inequalities such as, so we have less than, greater than, less than or equal to, greater than or equal to. Do you guys know those symbols?
Yes.
Yeah.
Okay, so hopefully those are familiar. So we start from less than, greater than, less than, equal to, greater than or equal to. So if it's parentheses, then you're using less than or greater than, one of those. You're not using the equal to sign. Equal to sign will go for closed set. So this will go for closed sets, and this will go for open sets. So hopefully you can see the connection. Now, if I want to use the same example, A comma B open in inequality notation, I would use X will denote any number between the interval A and B is less than B, and it's less than A. So that will be the inequality notation for A comma B. Now, can someone tell me the inequality notation for the closed set A comma B?
Is it A less than or equal to X less than or equal to B?
Absolutely. So you start putting in less than or equal to because it's a closed set. So hopefully you got an idea. Now you also want to put an infinity in the picture. So suppose, I'll illustrate it with an example. So suppose I have this graph where, let's say this is 5 and closed, and we shade everything to the right. So arrow indicates that it's going to go to the positive infinity direction forever. Okay, that's how we indicate it. So I want to express this set in interval notation and inequality notation. So I'll give you guys a few seconds to kind of think about this, and then we'll write down the answer.
Can you please repeat exactly what you said about the arrow, that it expresses that it's gonna go on forever.
Right. So here I put an arrow in the set. That means it's going toward positive infinity. And if I put it on the left side, that means it's going to go toward negative infinity. So looking at this graph, and we want to express it in interval notation, the lowest the set has is 5, right? So in interval notation, we're going to start from 5. Now the question is 5 included or not included?
It's included.
Included.
Right. So which symbol do we use?
The brackets.
Great. And then comma, and then, so the number is 5. What's the highest value on the set?
Infinity.
Infinity.
Infinity. Now, absolutely. So because infinity is not really a number, it's a symbol that stands for big numbers, we're going to put parentheses. Always parentheses. Okay? So now that I have, or any question on the interval notation? So this is always open. Okay. All right, so moving on to the inequality notation. Now, can someone give me the inequality notation for the same set? Coming in? Okay, I didn't hear. Go ahead.
Wouldn't it be 5 is less than or equal to x, which is less than infinity?
Oh, that's good. That's one way to write it. There's another way to write it, like simpler way.
Would it be 5 is less than or equal to positive infinity?
No, you have to put x in there somewhere because x represent any number within the set.
Can you do 5 is less than or equal to x? Just that's it?
Yeah, right? Or how do I rewrite this?
X is greater than or equal to 5.
Absolutely. So that will be the simpler form of the same thing that we have for number 1. So x is between 5 and infinity. Okay, cool. And 5 is included. That's correct. You can also say anything bigger than or equal to 5 is also a set. So any of these are acceptable. You could write this too, but we often like to use our variable first and then the inequality if it's only one directional set like this one. Okay, let me give you another example. That way we have at least a couple more to think about. Here's another example. So do the same thing, write down the interval notation and inequality notation. Okay, so I will have you guys do the interval notation and inequality. Okay, so take a couple of seconds. Okay, so someone tell me what's the interval notation for this set?
Parentheses, -2. 6 and brackets.
Absolutely. So you're in between those two values. The lowest is -2, open, and the highest is 6, including 6. Now someone tell me the inequality notation.
6 is greater than or equal to -2.
No, we need x in there. right? Does X represent any value within the set?
-2, oh, -2 is less than X, and X is less than or greater to 6.
Right? Yeah. So that would be the inequality notation, and this would be the interval notation. So remember, X is just any value within this interval. So X is kind of like a dummy variable. They represent any number within a given set. So when you're writing an interval notation, you have to bring in X. You have to tell me what are some values X that represents within that set. Okay? And there's one more thing that we need to talk about for this section is absolute value. And that's the last bit of P1. Well, absolute value, hopefully you guys know absolute value is kind of like a distance from the origin, so it's always positive. So by definition, we know absolute value of any number A, it's going to be A if A is greater than or equal to 0. It's going to be negative A if A is less than 0. So pretty much that's how we define absolute value. And I will do a couple of examples next time, just in case you guys want to go over a few more examples. So be ready to take a quiz on P1 and P2 on Thursday. We will have our quiz at the end of the class. So I will finish lecture around 11:20ish or 11:19. That way you have a minute or two to grab a snack or whatever. Water, and then you can start the quiz at 11:20. By 11:40 you should all be done. So that's for tomorrow, and the quiz will take place on WebAssign. So make sure you have access to WebAssign. You had plenty of time over the weekend to get access to it, so hopefully you guys did, so I wouldn't be saying much on that. Well, any questions before we say goodbye for today?
You said Wednesday, right?
Yep, Wednesday, which is next class.
All right. Thank you.
Yep. All right, so this is it for us today.